Okay, this is 2018, paper 2, and it's the higher paper. So let's work through all the solutions. This is question 1. And we're looking for the area under a curve between x equals 3 and x equals -1. So we just integrate that and then substitute in the values and do a subtraction. Okay, so we get 3x plus 2x squared over 2 minus x cubed over 3. Make sure you don't put your integral sign in when you've already integrated. It should be a square bracket. And then just tidy up where possible so we can make that just an x squared. Now sub in our 3. And then the -1. That first bracket will go to a 9. The second bracket will be a -2 and a +1/3. Okay, so since the first bracket was a 9. So now we'll just get rid of the bracket. So 9 plus 2, take away 1/3, which is 11. Subtract 1/3, which is the same as 10 2/3, or 32 over 3 units squared. So 32 over 3 units squared, or you can leave it as 10 2/3 units squared. Okay, question 2. You're asked to find u dot v, and all we do is multiply the top 2 components, the middle 2 components, and the last 2 components together, and then add. So 7 plus 32 minus 15, and we get 24. So u dot v equals 24. Part B. Calculate the angle between u and v. On your formula sheet, you'll have, it won't use u and v's, but it shows you this formula. So it's the magnitude. So u dot v equals the magnitude of u, magnitude of v, cos theta. So actually, we don't have those answers to pop in yet, so let's do that over the side. So the magnitude just means the length. So the magnitude of u is -1 all squared plus 4 squared plus -3 all squared, square rooted. And that is root 26. Do the same to find magnitude of v. So just the components of v, all squared and square rooted. So that's square root of 138. Okay, now we can bring them along to the other side. So we know u dot v is 24, so put that there. We know the magnitude of u is root 26, magnitude of v is root 138, and cos theta, we don't know theta, so we're going to rearrange to find out. So we can just do 24 divided by whatever root 26 times root 138 is, and that will be the same as cos theta. And then once you've got your answer in your calculator, just do shift cos answer. When I simplified that down, it came up as this on the calculator, so I'm just going to type that in. And your answer is 66.38 degrees, so that's the angle in between u and v. Question 3. We have f of x equals x cubed minus 7x minus 6, and we're asked if it's increasing or decreasing when x equals 2. So all you do is differentiate and substitute in your 2. If it's positive, it'll be increasing, and if it's negative, it'll be decreasing. So let's find out. 2 squared is 4, 4 threes are 12, take away 7, and we get 5. So therefore, the function is increasing as f dash of 2 is greater than 0. Question 4. This is a complete in the square format. So all we want to do is take out the negative 3 as a common factor for the first two terms. Be careful with that sign. So it would be a 2x because 2 3s are 6. So be careful with that sign because a negative times by a positive is negative. And we want to make negative 6x in the middle, so we need to have a positive sign there, a plus. If we had a negative symbol, a negative times a negative would be plus, and that wouldn't be correct. So just be careful with that sign in the bracket. And we're just going to keep the plus 7 for now. Okay, so x squared, we're going to square this bracket out and we want to make x squared plus 2x. So the first term would be an x and the last term would be a plus 1. We just half the 2 and we get 1. Now if we were to multiply that bracket out, your last term, let me multiply it over. You don't need to do this work, but if you're not too sure what you're doing, multiply that out at the side and you'll get x squared plus 2x plus 1. Now if you multiply that by negative 3, let me put a negative 3 on here, your last term is going to be negative 3 instead of plus 1. So we want to make plus 7 from negative 3, so we're going to have to add on an extra 10. And that's your final answer. Negative 3 bracket x plus 1 all squared plus 10. Question 5. These are just perpendicular bisector questions. The diagram doesn't look too nice, but it's nice and easy. So you've got your P and Q, and this line, L1, is bisecting it. Now my diagram probably doesn't look like it, but it should be cutting it exactly half. And it's cutting it at right angles because that's what perpendicular bisector means. It's going to cut at right angles in the middle. So we know P is 3, 4. We know Q is 9, negative 2. So we want to find, this is where we'll do point gradient equation. Okay, so the point will be your midpoint. The gradient is going to be a perpendicular gradient of PQ, and then we'll go and find our equation after that. Okay, so the point is midpoint, so do 3 plus 9 all over 2 and 4 plus minus 2 all over 2. So that is 12 over 2, which is 6, 2 over 2, which is 1. So that's our midpoint. The gradient, if we do, just be careful to label it so we don't make a mistake. x1, y1, x2, y2. Okay, so do your gradient formula. Negative 6 over 6, so negative 1. Perpendicular to that is going to be 1, since m1 times m2 equals negative 1. Okay, the equation. So y minus b equals mx minus a. Our point is the 6, 1. So it's y minus 1 equals 1 bracket x minus 6. That's nice and easy, just get rid of the 1. And then we just want to add the 1 onto the negative 6 to make negative 5. Y equals x minus 5. On to part B. So we have to calculate the coordinates of C, which is a point of intersection of L1 and L2. So L1 we just found out was y equals x minus 5. L2 we have been given, which is 3y plus x equals 25. So what I'm going to do is I'm going to do simultaneous equations. I'll call that equation 1. I'm going to rewrite the first equation there, so it's in the same format. I'm going to call that equation 2. And then I'm just going to add both equations. We've got a plus x and a minus x, so that's nice. It's going to work out nice. So 3y plus y equals 4y. The x's will cancel. 25 plus negative 5 is positive 20. And then just divide, so y equals 5. Okay, if we go back to equation y equals x minus 5, then we can just pop the 5 in the y position. So 5 equals x minus 5, so x will equal 10, because you'll add the 5 onto the other side. So, and I'll just rewrite that. So x equals, actually we're going to put it as a coordinate anyway, so therefore c will be 10, 5. Okay, so to get the equation of this circle, you just need to know the centre, which is 10, 5. And you need to know the radius. So we're going to draw the circle quickly for you. So the centre is here, and you know that P is on the edge of the circle, and it's 3, 4. So if you can just do the distance formula between 3, 4 and 10, 5, that'll give you the radius. So the radius is going to be x2 minus x1 all squared plus y2 minus y1 all squared. So 10 minus 3 all squared plus 5 minus 4 all squared. And the square root, which is 7 squared plus 1 squared, which is root 50. Now you just pop it into x minus a all squared plus y minus b all squared equals radius squared. You have to use the centre, so x minus 10 all squared plus y minus 5 all squared equals 50. Square root of 50 squared would just be 50. Question 6. Okay, we know f of x is 3 plus cos x and g of x is 2x. Firstly, we're asked to find f of g of x. So that just means we're going to replace our g of x into the f of x function. So we're going to put the 2x in the f function where we see x. Part 2, g of f of x. So it's g of 3 plus cos x. All that means is we're going to pop the 3 plus cos x into the g function where we see x. So it's 2x, so it's going to be 2 of this bracket. Just multiply that out, so 6 plus 2 cos x. Okay, part B. It's telling us that it's equal to each other and they want us to solve it. So we'll just do 3 plus cos 2x equals 6 plus 2 cos x. Bring everything to the left. Now we need to replace, just use your addition formula. So cos 2x is 2 cos squared x minus 1. So 2 cos squared x minus 2 cos x minus 4 equals 0. So 2 cos x equals 0. 2 and 2 multiply to make 4. If we make that a minus and make that a plus, then it's minus 4 plus 2, which makes the minus 2 in the middle. Perfect. Okay, so now we just put both parts of the brackets equal to 0. So if you move the plus 2 over, it will become negative 2 and then divide by the 2 at the front, so negative 1, and cos x equals 2. Now that's impossible because cos has to be between 1 and negative 1, so just rule that one out. Okay, when cos x equals negative 1, 0 or 1, I just look at the graph rather than doing cast diagram work because it's a lot easier. So if we look at a cosine curve, what angle is it at negative 1? It's at 180 degrees. You're asked to give your answer in radians, so you must leave it as pi. So x equals pi. On to number 7. Okay, we're going to show that x minus 2 is a factor. So if it's x minus 2 is the factor, you make sure you put the positive 2 on the L shape. And if you've got any terms missing, make sure you put a 0 for their coefficient. There's no zeros to be put here, but just bear that in mind. That comes up quite a bit. Okay, so just bring the 2 down below and then do 2 times 2 is 4. Add, we get 1. 1 times 2 is 2. Add, negative 3 plus 2 gives us negative 1. Negative 1 times 2 is negative 2. And add, we get 0. Okay, and you can just say, since the remainder is 0, x minus 2 is a factor. Part 2, factorize fully. Okay, so the function is going to be x minus 2 to start with. Don't forget that first bracket, you'll lose a mark. Okay, so x minus 2 is your first bracket, and then it's 2x squared plus x minus 1. We get those 3 answers from these 3 numbers here. Okay, so 2x squared plus 1x minus 1. And then fully factorize. And other times you can't. Sometimes you cannot simplify this bracket down, but we can, so make sure you do that. Okay, it's going to be a 2x minus 1 and an x plus 1. And that's us fully factorized. 7b, show that u7 equals 2a cubed minus 3a squared minus a minus 1. So we know that u5 is 2a minus 3. And we know that un plus 1 equals aun minus 1. So u6 is going to be au5 minus 1, which is a times 2a minus 3 minus 1, which is 2a squared minus 3a minus 1. u7 will be a times, I'll write it like this first, a times u6 minus 1, and then put my u6 in, so I'm not confusing you. And don't forget that minus 1 at the end. Okay, so 2a cubed minus 3a squared minus a minus 1 as required. So that's what they give us, and we got it to that, so that's good. Okay, this is 7c part 1. You're told that u7 equals u5, and you're also told that a limit exists. So all we do is put our answer to u7 from the previous part equal to our u5 answer. Bring everything to the left hand side. So you subtract 2a from the negative a, and you'll get negative 3a, and then add 3 onto the negative 1, and you get plus 2. Now at this point you should notice that this was the question you started with in 7a. The only difference is there's the a's instead of the letter x. So you actually have already solved that polynomial. So we should know the answers. All we'll do is put it into the factorized form using a. So instead of x minus 2, it's a minus 2. So that was our answer to our fully factorized form in part A. So now we'll just solve it. So a equals 2. A will be a half, or a will be negative 1. Now for a limit to exist, the a value must be between negative 1 and 1. So there's only one answer. So therefore a has to be 1/2. This is C part 2. we're actually asked to calculate the limit. So limit equals b over 1 minus a. And remember, you always have to say that a limit exists because a falls between -1 and 1, but I've already mentioned that, so I'm not going to say it again. Okay, to get your b, let's go back to the original recurrent solution. That was un plus 1 equals aun minus 1. So our a was a half, and our b is the -1. So -1 over 1 minus a half, -1 over a half, multiply your 2 up, so -2. Question 8. Okay, this is a wave function question. And it's in degrees. Okay, so if we expand that out, we get k, and then just do your cos expansion. So cos, sin. Just remember to change the sign when it's a cos expansion. And then multiply that k through. Now we're just going to equate coefficients, so we're going to write that k cos x cos a equals 2 cos x. The cos x is cancelled, and you've got k cos a equals 2. Now we'll do that k sin x sin a equals minus sin x. Don't forget that negative. And that negative means -1. Okay, to find k, we just square and square root the values. So 2 squared plus -1 squared is √5. Okay, to do the tan. Tan is sine over cos. So k sine a over k cos a will also give you tan because the k's will cancel. So -1 over 2 minus a half. Let's check what quadrants it's going to be in. Okay, the k cos a is 2, which is positive for cos, so it's in these two quadrants. Sine is negative in these two quadrants, so it's going to be quadrant 4. Tan will also work out. I just don't bother ticking that one because it's not necessary, but tan is negative also in quadrant 4. So first step is to find your acute angle, which is inverse tan of positive a half. And that is 26.6 degrees. So our angle is 360 minus 26.6, which is 333.4 degrees. Okay, so over at the side here, our answer is k, which is √5, and then cos x minus 333.4. Okay. Okay, this is B part 1. We're asked for 6 cos x minus 3 sin x to find the minimum value of this. You should notice this is 3 times bigger than the wave function you've just been asked to work out. So that in the wave function format it would be 3√5 cos x minus 333.4. Okay, the minimum value, the max is going to be 3√5 and the minimum will be -3√5. So the minimum value is -3√5. When does this occur? That's part 2. Okay, the quickest way of doing it is just checking a regular cosine curve. So the cosine curve, its minimum value occurs at 180 degrees. Okay, that's 180 degrees there. So all we do is put our bracket equal to 180. So because it's minus, we'll add that on to 180. And we get 513.4 degrees. Okay, 513.4 is out of our range, but we know that every sine and cosine curve repeats every 360 degrees. So all we have to do is subtract 360 from 513.4 to get our answer. So that is 153.4. So x equals 153.4 degrees. Number 9. Number 9 is an optimization question without a part A, which is quite nice. Okay, so we're asked to find the minimum value of P. So first of all, we have to find the minimum value of x that would give us the minimum value of P, or the value of x that will give us the minimum value of P. So let's differentiate. Actually, before we differentiate, remember you don't want any letters on the bottom, so bring that up with a negative power. Now we're ready to differentiate. And then tidy that up because we're going to sub some stuff in, so you want it nice. Okay, just always mention that P dash of x equals 0 for stationary points. And then we'll put it equal to 0. Now you can multiply your x squared up. So 2x squared equals 128. So x squared equals 64. So x equals the square root of 64, which is plus or minus 8. It can't be negative 8. That's impossible because you can't get a negative length. So x equals 8. You don't need the plus sign in front of it, but it was just to make it obvious that it was plus or negative. Okay, let's do a quick nature table to prove that it's minimum when x is 8. So in this middle section, you're going to write P dash of x. So you write the differentiated form, whatever it's in. It has to be 0 below the 8. Okay, the arrow before the 8 just means pick any value less than 8 and substitute it into your P dash of x. Because x is on the bottom, you can't use 0 because that does not make sense. So make sure you choose a different number. I chose 1, and when I substituted 1 in, I got negative 126, so that's negative. A number greater than 8, I chose 10, because it was nice and easy to work with, and I got 0.72, which is positive. So therefore, I got a minimum. So therefore, min perimeter when x equals 8 centimeters. You were also asked to find the value of P. So P of 8 equals 2x plus 128 over x, but we know where x is 8, so 16 plus 128 divided by 8 is 16 as well, so 32. And perimeter is just the length, so 32 centimeters. Number 10. X squared plus m minus 3x plus m equals 0. Let's do the discriminant. Okay, for this one it says real and distinct roots. If it just says real roots is greater than or equal to 0, but if it says real and distinct, it means you want two different roots, so the equal 0 does not count. So make sure you just have a greater than sign and not a greater than or equal to. So b squared minus 4ac is greater than 0 for real and distinct roots. So always write a little comment to explain what you're doing. Okay, so the b is your m minus 3, your a is 1, and your c is m. So m squared minus 6m plus 9 minus 4m is greater than 0. So m squared minus 10m plus 9 is greater than 0. Now I'm going to factorize this and I'm going to put it equal to 0 just so I can sketch. So I'm just going to write equals 0 for roots. This is just to find the roots. It doesn't equal 0, but it's just so I can sketch it. So m minus 9 equals 0, so m would equal 9. M minus 1 equals 0, so m would equal 1. Okay, now we're just going to sketch the graph. So it's cutting at 1 and 9. When is that graph above the x-axis? When is it greater than 0? So m squared minus 10m plus 9 is greater than 0 when m is less than 1 or when m is greater than 9. So that's your answer. Okay, question 11. It's talking about p% of customers who wait for less than t minutes. And they can be modeled by p equals 100, 1 minus e to the kt. Okay, so p is the percentage of customers who wait for less than t minutes. So part A, if 50% of customers wait for less than 3 minutes, you would do 50 equals 100. And because it's saying less than 3, that just means your 3 will be your t value, because the question stated that t represented less than a certain number of minutes. So all we do is tidy this up and take the lens of both sides. So 50 divided by 100 would be 0.5. I'm going to move e to the 3k to the other side and make it positive. I'm going to add it on to the left, and then I'm going to subtract the 0.5 off the 1. Now I'm going to take ln of both sides. Ln e cancels, and you're just left with you can just bring the power down to the front. That's the whole point why we do it. So 3k equals ln 0.5, and now k will just be a division by 3, and we get negative 0.231. So that's our k value, negative 0.231. Part B. Calculate the percentage of customers who wait for 5 minutes or longer. We are going to need to find the percentage that's less than 5 minutes. And then from that, we'll be able to work out our answer. Okay, we're going to do P equals 100, 1 minus e to the negative 0.231 times 5. And that will tell us how many waited for less than 5 minutes. So all we do is substitute that into a calculator, and we're going to get 68.5%. So if 68.5% waited less than 5 minutes, then if we want to know how many had to wait for 5 minutes or longer, we just subtract that from 100%. And we get the answer of 31.5%. So 31.5% of customers had to wait 5 minutes or longer. Question 12. Okay, part A, part 1 wants the coordinates of the centre of C1. That's really easy, just look at the brackets. So it's x minus 13 all squared, so your x value is just going to be 13. The second bracket is y plus 4, so you'll just change it to a minus 4, and your centre of C1 is 13, negative 4. Part 2. The centre of C1 lies on the circumference of C2. Show that C equals negative 455. All we do is, we've got our circle equation, so we just want to substitute the values in and rearrange for C, and hopefully we'll get negative 455. So the centre C1 lies on that, so we're going to substitute the C1 in. Okay, when you tidy that up, you get 169 plus 16 plus 182 plus 88 plus C equals 0. And if you add the first four numbers together, you're going to get 455 plus C equals 0. And then obviously, if you subtract that off the 0, you'll get negative 455 as required. Okay, this is 12b part 1. This is where we were asked to determine the ratio in which P divides the line joining the centres of the circles. So the centre of C1 is 13, negative 4. The centre of C2 is negative 7, 11. I'll show you how I get that. So we put 2g equal to 14, g equals 7. This is from your equation. I'm getting the values 14 and negative 22 for 2f. So f equals negative 11. So the centre of C2 is negative g, negative f. So negative 7, 11. We also want to find the radius. The radius of the large circle will be the distance from C1 to C2. So you could actually use a distance formula since you know both of those, but I'll just use the formula, which is g squared plus f squared minus c, which is 7 squared plus negative 11 all squared plus 455. And that's in a square root, which is 625. And the square root of that is 25, so the radius is 25. That means the distance between C1 and C2 will be 25 because that's the same length as the radius if you look at the diagram that you were given. Okay? Right, the radius of the smaller circle will just be the square root of 100 if you look at that nice easy equation. So the square root of 100 is 10. So the distance between C1 and P would be 10. Now, if the full length is 25, that means the distance from P to C2 will be 15. Therefore, P divides C1 and C2 in the ratio 10 to 15. Whereas if you simplify that down by dividing by 5, you'll get 2 to 3. So that's your answer for B part 1. Okay, we've just found out that P divides C1 and C2 in the ratio 2 to 3. So the distance from C1 is down here, to P is 2 parts, and C2 is up here. So the distance from P to C2 would be 3 parts. So that's a ratio 2 to 3. Now that means ratio parts, not length. So you should be able to see that the distance from C1 to P would be 2/5 of the full length. So I worked out that it's 20 places to the left if I start at 13, negative 4 and I want to move to negative 7, 11. So to get from 13 to negative 7, I'm going to go 20 places to the left. To get from negative 4 up to 11, I'm going to move up 15 places because negative 4 plus 15 makes 11. So what I'm going to do is I'm going to find out what 2/5 of 20 is. 2/5 of 20 is just 20 divided by 5 is 4, 4 2s are 8. And 2/5 of 15, 15 divided by 5 is 3, 3 2s are 6. So what I'm going to do now is, instead of moving 20 places to the left, I just want to move 8 places to the left. So I'm going to start off with my x value of 13 and I'm going to subtract 8. And I get 5. Then instead of moving up 15 places, I only want to move up 6 places. So I'm going to do minus 4 plus 6, which is 2. That means the coordinate of P is 5, 2, because 5 would be how far across you go, and 2 is how far up. So that's our y value, the 2. So P equals 5, 2. Okay, for C, it says P is the centre of a third circle, C3. C2 touches C3 internally. So C2 touches C3, it just means that will be tucked inside the C3 circle, and P is the centre of the larger circle. Now, from previous, we found out that the radius of C2 is 25. That means its diameter is 50. Okay. So, because we know the radius of the other circle of the smaller circle is 10, that distance that I've marked on is 10. So if the diameter is 50, that leaves us with 40 here. That means, because P is the centre, that means the radius of our new circle has to be 40. And we know the centre is 5, 2, so it's just x minus 5 all squared plus y minus 2 all squared. equals 40 squared. So x minus 5 all squared plus y minus 2 all squared equals 1600. And that's us find the equation of C3. So just to go back over it, the 10 is the distance from P to the edge of that circle, because we know the radius of C1 was 10 and that's the same distance. And because the diameter of the larger circle is 50, that we know that it must be a gap from P to the edge, must be a distance of 40, and that's why the radius is 40 for circle C3.